Hi and good morning to doctor. My name is Chang. Today I will present my project on the title name is Detection and Classification for Autism Spectrum using machine learning based image processing. So the goal of this project is to develop a convolutional neural network which is known as CNN model that can classify the facial image as either autistic or non-autistic. So now let's talk about the dataset and how it was prepared. For this project, I used the dataset from Kaggle. It's named autism image data, which consists of image categorized into two classes, autistic and non-autistic. To improve the model performance, I apply the preprocessing techniques such as the normalization and data augmentation. Without further ado, let us begin with the codes. The first step is ensure that the needed library is imported, and this library are essential for building and training the model. And TensorFlow and Keras are used for deep learning implementation, while the matplot and the seaborn is help to visualize the result. And lastly, the image data generator is used for data augmentation. The next step is to define the dataset path. The dataset was loaded using the TensorFlow function, and these are the folder path where the dataset is stored, and the dataset is split to three set, which known as the training set is used for the train the model, and the validation set used for tune the hyperparameters and avoid the overfitting, and lastly the test set is to use to evaluate the final model performance. So next step is to define the image parameters. The image are resized into 128 times 128 pixels, and the batch size is equal to 32, which means the number of the image processed at a time. Help with the memory management, of course. And the next step is the data preprocessing and augmentation. So normalization and augmentation technique will apply in this step. So you can see that rescale equal to 1 dot slash 255 means for normalizing the pixel value to 0, 1 range instead of 0, 255, which help with the model faster training. So for the data augmentation part is for the training set, is means for the randomly rotate the image by 20 degrees, and this two line is stand for shift the image horizontally or vertically by 20%, and the last line, this line stand for the flips the image horizontally to increase the dataset variability. So the validation set and test data only use the rescale, which to maintain the consistency without the augmentations. So yeah, let's proceed with the next. And so the load data training dataset and the CNN model is compiled using the Adam optimizer and trained using the fit function while monitoring the validation's accuracy. So you can see here when I load the training data, it will found 2540 image with belonging to two classes, which is autistic and non-autistic. So did the validation data, found 100 image belonging to two class. The test data 300 image belonging to the two class. So I can explain from here. The same things is the flow from directory. It means that load the image from directories, resize them and prepare them for training. And the target size is resize all the image to 128 times 128 pixels, and the batch size is load equal to 30 means 32, sorry, means loads the 32 image at a time, and the class mode equal to binary because we are doing the binary classification, like 0, 1 autistic or not autistic. So the shuffle equal to false is for the test data, as you can see. Uh, it is ensuring the test image order remain the same for evaluation. So we proceed to the next, the CNN model. So the Keras sequentials is used here to create a sequential model where each layer is added step by step. So the input layer, Keras.input is define the input image shape as 128, 128, 3, where 3 represent the RGB channels. And the convolution layers is to extract the feature from image and use the ReLU activations to introduce the non-linearity. And the number 32, 64, 128 represent the number of filters, which is the feature detectors. And the 3 is the filter size, which means that 3 times 3 window. And for the pooling layers is the mass pooling 2D, 2, and it used to reduce the image size while retaining important features such as preventing the overfitting condition occurs. And for the flattened layer is convert the 2D features map into a 1D vector for input into the dense layers. And lastly, the fully connected layers known as dense. For this line is stand for to fully connected the layer with the 122 neurons, and the dropout is means randomly drop 50% of neuron to prevent overfitting. And the last line is stand for the output layer is sigmoid for binary classification. And let proceed to the next compound model. And for this is the optimizer using the Adam is the adaptive learning rate optimizer, effective for the deep learning. And for this is the binary classification task. And for this matrix means evaluate the model performance based on the accuracy. And we proceed to the next is the train model. And the model will go through the dataset 20 times. So it show here epochs equal to 20. And I also train the model using the training and validation dataset. And for this warning, it's just an environment warning, which is can be ignored to because it won't affect the result also. So yeah, we proceed, and after the code run, it will show it running the training the epoch training while training the model. So in this section is to plot the training and validation loss and the accuracy curve graph, and it helps to visualize how the model is learning over the epoch. So let's see the result. And for this loss curve, as you can see, the blue line stand for the training loss and the orange line is stand for the validation loss. So the training loss is gradually decreased over the epochs, which means the model is learning and improving. And for the validation loss, it fluctuates but generally decreases, which is a good sign. However, the high fluctuations suggest that the model might be slightly overfitting to the training data. And for the accuracy curve, it's also same. The blue line stand for the training accuracy and the orange line stand for the validation accuracy. So for the training accuracy, the accuracy steadily increase over the epoch, which means the model is learning well. And for the validation accuracy is quite unstable with sharp up and down fluctuations. And this indicates that the model is inconsistent on unseen data, which might suggest the overfitting. So without further ado, let's proceed with the next step is a safe model. For this section is generate the is to save the train model as an HDF5 files for future use and evaluate the validation accuracy after the training. So after that, it generate the for this step is for the warning is also the environment warning. Can just ignore that. And for this step is the compute the classification report and the confusion metric, which generate the prediction and compute the classification report and visualize the confusion metrics. And we can discuss about the classification report. So the classification report show that the overall performance and the model achieve a 77% precision, meaning that when it is predict a sample as either autistic or not autistic, it is correct 77% of the time. Similarly, the recall score of the 77% indicate that the model correctly identifies 77% of actual autistic and non-autistic case. And the advanced score, which balance the precision and recall, is also 77%, suggests that the model maintain a consistent trade-off between the correctly identifying positive case and minimize the false positive. So the datasets used for the testing is balanced with 150 samples per class for the autistic and non-autistic, and ensuring the model does not favor one class over the other. And the overall accuracy of 77% indicate that the model correctly classified the 77% of all test image. Additionally, both the macro average and the wedge average score also 77%, confirming that the model performance is consistent across the both classes. And for the confusion metrics, as you can see, it showed that the 150 actual non-autistic cases, the model correctly classified the 116, but misclassified the 34 as autistic. Similarly, for the 150 actual autistic, the model correctly identified 115, but misclassified 35 as non-autistic. This misclassification indicates some level of confusion between the two classes, which may be due to the overlapping feature or limitation in the model ability to distinguish the key pattern. So the last code is to predict on the test data and print out the test accuracy, which is the 77%. And that's all for me. Thank you.